In this video we're going to continue with the integration topic, and we're continuing on with area, and this time we're looking at the area between curves. So say we've got something like this, and we can see that the green curve here, the one with the minimum turning point, is y equals g of x, and the blue curve with the maximum turning point is y equals f of x. We can see that f of x and g of x intersect each other, and we can see that the x-ordinate of one of the points of intersection is A. So we've got x equals A here, and we can see that the x-ordinate of the other point of intersection is B. So in general, we can find the area enclosed between two curves, between x equals A and x equals B, by using the integral between A and B of f of x minus g of x with respect to x. Now, it's very important here that this subtraction, what we're subtracting from, is the upper curve. So you can see the f of x here is on the top of the area, if you like. Okay. And g of x is the lower curve. So what you're subtracting is the lower curve. Okay, so you can see that that's underneath the area that we're interested in. And that's really important. If you do it the other way around, you're going to get a negative area, which obviously you will know by now. We can't have a negative area, so you need to make sure that you're doing this the correct way around. You'll also notice, given this example here, that g of x is written first. It's that almost seems like the upper one, and f of x is the lower one, but you need to really look at the curves themselves and not the writing that accompanies that, not the annotations. Okay, so you can see here f of x is on the top of the area and g of x is on the bottom of the area. Okay, so example 1 then, folks. We've got calculate the shaded area enclosed by y equals 4x plus 16 and y equals 2x squared plus 10. Now, if I just look at the area firstly, the first thing I want to do is identify the upper curve and the lower curve. Okay, so the upper curve here is my straight line, which is in blue. That's on the top of the area. Okay, so that's 4x plus 16, and my lower curve is 2x squared plus 10. I've been given the points of intersection between the line and the curve. I can see that I've got negative 112 and 328. Now for my limits, I'm only interested in the x-ordinates. So you can see that I'm integrating between negative 1 and 3, the x-ordinates of the points of intersection, of 4x plus 16 minus 2x squared plus 10 with respect to x. Now you can hopefully see that the 16 and the 10 will simplify here. So you want to try and make life when you're integrating as easy as possible. So we can rewrite that integral as 4x minus 2x squared plus 6, and we're integrating that between negative 1 and 3 and integrating with respect to x. So I'll get 4x squared over 2 minus 2x cubed over 3 plus 6x, and you can see I can simplify that first term to 2x squared and the rest stays the same. Okay, so minus 2x cubed over 3 plus 6x, and my limits were negative 1 and 3. So firstly substituting in 3 here, so I've got 2 times 3 squared minus 2 times 3 cubed all over 3 plus 6 times 3, and I'm subtracting the same expression with negative 1 substituted in. So 2 times negative 1 all squared minus 2 times negative 1 all cubed over 3 plus 6 times negative 1. And evaluating all of that, I get 18 minus 18 plus 18. I'm subtracting my second bracket, that gives me positive 2 plus 2/3 minus 6. Okay. And then for my first bracket, I'm left with 18 after all that. And the second bracket, I'm left with negative 3 and 1/3. You can see we're subtracting a negative here, which is adding, so we've got 21 and 1/3, and we need to remember our units here. So it's an area, so we've got square units. So just now would be a good time to pause the video and take this example down in your notes, and we're going to do another 2 examples. Okay, welcome back folks. So example 2 now. And we want to calculate the shaded area enclosed by the curves with equations y equals 6 minus 3x squared and y equals negative 3 minus 2x squared. So again, as always, I want to identify my upper and lower curves here. Okay, so I can see the one on the top of the area is 6 minus 3x squared. The one on the bottom is negative 3 minus 2x squared. Okay. Now, I also notice here I've not been given the points of intersection. I can see the points, but I've not been given what those points are. And I need those for my limits. I need the x-ordinates for my limits. So these are both y equals. So using substitution, I can equate these. Okay, so I've got 6 minus 3x squared equals negative 3 minus 2x squared. And I've added my 3x squared to both sides and added 3 to both sides to get 9 equals x squared. Solving gives me x equals the square root of 9, which is positive and negative 3. Now, for the limits, I only need the x-ordinates of my points of intersection, so I don't need to substitute back in and find y at this stage. I'm just interested in my x-ordinates because that provides me with my limits for integration. So I'm integrating between negative 3 and 3, 6 minus 3x squared minus negative 3 minus 2x squared, and I'm integrating with respect to x. Now hopefully you can see that that will simplify here, so I'm actually integrating 9 minus x squared. And that will give me 9x minus x cubed over 3. My limits were negative 3 and 3. So firstly substituting in my upper limit, which was positive 3, and then substituting in my lower limit, which was negative 3. So my first bracket, I'm going to get 27 minus 9. In my second bracket, negative 27 plus 9. That gives me 18 minus negative 18. And you can see that that will give me 36 square units. So just now would be a good time to pause the video before we get to example 3. And you can take this one down in your notes. Okay, welcome back folks. So example 3, slightly different this time. We've got two functions and they're defined by x as in the real. So example 3 this time, we've got two functions and they are defined by x in the real numbers by f of x equals x cubed minus 7x squared plus 8x plus 16 and g of x equals 4x plus 4. The graphs of f of x and g of x are shown below. Calculate the shaded area. Now, hopefully you can see folks that there are two separate areas here. Okay, so we've got the area between negative 1 and 2. Part, and we've got the area between 2 and 6, which is this part. So we need to find two separate areas. It's like a compound area, which you'll have done in second, third, fourth year, whenever, okay? So you need to find separate areas. So we need to integrate twice here, two separate integrals. So let's take the left-hand side first. We'll call that area 1, okay? And we're integrating between negative 1 and 2. And we can see that our upper curve at this point is the green one, that's the cubic. So that's f of x equals x cubed minus 7x squared plus 8x plus 16. And we are subtracting 4x plus 4, which is g of x. Okay. So you can see what's happened there. Hopefully we've got our upper minus our lower, but for this first area. Now we can simplify this slightly to ease the integration a bit. So we've got x squared minus 7x squared plus 4x plus 12, and we're integrating that between negative 1 and 2 and with respect to x. So integrating will give us x to the power 4 over 4 minus 7x cubed over 3 plus 4x squared over 2 plus 12x, and you can see our 4x squared over 2 will simplify to give us 2x squared. Now substitution will give us this long expression here. So we've got 2 to the power 4 over 4 minus 7 times 2 cubed all over 3 plus 2 times 2 squared plus 12 times 2. We are then subtracting the expression with -1 substituted in. So -1 to the power all to the power 4 over 4 minus 7 times -1 all cubed over 3 plus 2 times -1 all squared plus 12 times -1. Our first bracket gives us 4 minus 56 thirds plus 8 plus 24. And we're subtracting 1/4 plus 7 thirds plus 2 minus 12. And we can now look at all of our whole numbers. Okay, so I've got 4 plus 8 plus 24, which is 36. I'm subtracting my 2 here to give me 34, and then I'm adding 12, so that gives me 46. I've then got -56 thirds, and I'm subtracting 7 thirds to give me -63 thirds, and then I've got this -1/4 here as well. I can see that 63 thirds gives me 21, so I've got 46 minus 21 minus 1/4. 46 minus 21 is 25, and 25 minus 1/4 is 24 3/4 square units. Now, we've got another part of this question to do. We've only found this area just now, so we need to find this area as well between 2 and 6, but I'm going to change the slide because I've run out of a bit of space here, so I would pause the video just now, take this bit of working down, and then come back for the next part of the question. Okay, welcome back folks, so hopefully you've caught that. I've got it here, but it's a lot smaller. You can see I've taken the question away, but all of the information we need is in the graph. Now, if we look at the area we've not found yet, you'll see that the straight line is on top now. That's the upper curve. So it's actually g of x minus f of x. And you can also see that the limits this time are between 2 and 6. Okay. So we've got 4x plus 4 minus x cubed minus 7x squared plus 8x plus 16, and we're integrating that between 2 and 6 and with respect to x. Now I can simplify that. I'm going to get negative x cubed plus 7x squared minus 4x minus 12. And again, integrating between 4 and 6 and with respect to x. Now, you may notice the expression I had earlier, okay? So it was actually the expression I've currently got, but multiplied by -1, okay? So when you're integrating, obviously, you may have made a mistake the first time, you never know. So you can integrate this again, but they should sort of match. The only difference is that it's been multiplied by -1. Okay, so you can see there that this matches down here. It's just one is been multiplied by -1, like I keep saying. Okay, so we can substitute in our 6 and our 2. Okay, so we get -6 to the power 4 all over 4. Plus 7 times 6 cubed all over 3, minus 2 times 6 squared, minus 12 times 6. We're then subtracting the negative of 2 to the power 4 all over 4, plus 7 times 2 cubed all over 3, minus 2 times 2 cubed, minus 12, sorry, that was minus 2 times 2 squared, minus 12 times 2. Right, so evaluating all of that, this one gives us negative 324 plus 504 minus 72 minus 72. We're then subtracting negative 4 plus 56 thirds minus 8 minus 24. So we're starting to deal with slightly larger numbers and larger negative numbers, if you like. Okay, we can see that this first bracket gives us 72 and the second bracket gives me 18 and 2/3. And 72 minus 18 and 2/3 gives me 53 and 1/3 square units. Now I'm still not finished folks, because I've just found the two separate areas. I need to find the total shaded area. So the total area is 24 3/4 square units plus 53 and 1/3 square units. And altogether that gives me 78 and 1/12 square units. So just now would be a good time to pause the video before the screen goes blank and make sure you've got this copied down in your notes and complete the assigned exercise for today as well.